A single stone at Puma fits another so perfectly that not even light passes between them. This is the reality of the precision stonework that defies primitive tools, an ancient mystery carved into the Bolivian highlands. By the end of this, you will understand why this site forces a complete re-examination of what ancient cultures were truly capable of. How did builders without modern technology achieve cuts finer than a razor's edge? And what catastrophic event scattered these megaliths like toys? The answers challenge the very timeline of human innovation. What does it mean for our history when the stones themselves seem to whisper of a forgotten science? But before we can examine the cuts, we must stand where the builders stood. The name Puma translates to the gateway of the Puma, a title that hints at its original grand gateway within the vast complex. This is not a remote outpost, but the heart of a once thriving spiritual and political center, perched in the Bolivian Andes at a breathtaking altitude. To put that height into perspective, it sits more than 2,000 feet higher than the peak of Mount. At over 12,000 feet, the air is thin, the sun is intense, and the wind carries a constant chill. In this environment, every breath is labored, and every physical task demands immense effort. For an ancient culture to choose this severe, exposed plateau for their most ambitious architectural project is the first clue that we are not dealing with ordinary builders. They were making a deliberate, staggering statement. The very location defies practicality, elevating the site from a mere construction into a profound declaration of presence and capability. It is against this dramatic backdrop of sky and stone that the real anomaly comes into focus, for the structures that remain here possess a cool, machined elegance that feels completely alien to the rugged landscape surrounding them. This jarring contrast between the primitive challenges of the environment and the advanced artistry of the masonry is what sets the stage for the central puzzle. How could a culture wrestling with the fundamental hardships of high-altitude survival simultaneously master a stoneworking technology that appears to leapfrog centuries of innovation? The stones themselves tell the first part of this impossible story. Scattered across the plateau are dozens of massive, intricately carved blocks known as the H-stones, named for their distinctive, repeating shape that resembles a capital letter H. To call them blocks is almost an insult. For they are not crude lumps of rock. They are complex, three-dimensional puzzles carved from andesite, a volcanic stone so dense and hard it ranks just below diamond on the scale of mineral toughness. Working this material with primitive tools would be like trying to carve a detailed sculpture into a granite countertop using only a butter knife. The sheer hardness of the stone is the first barrier that defies conventional explanation. Yet, the real mystery is etched into its surface. Each face of these H-stones is adorned with a series of long, shallow grooves. These grooves run in perfectly straight, parallel lines along the entire length of the block. There are no wobbles, no deviations, no signs of a stonemason's hand slipping or a tool catching. They look less like chisel marks and more like the precision cuts from a modern milling machine, the kind used to manufacture engine parts. The flat surfaces between these grooves are not merely flat, they are flawlessly planar, meeting at crisp, 90-degree angles that are consistent to within a tiny fraction of a single degree across every single block. This level of geometric perfection is not just skilled craftsmanship, it is evidence of a standardized manufacturing process. Imagine finding 100 identical, complex plastic pieces, and then being told they were each individually whittled by hand from blocks of solid plastic with no measuring tools. The mind rejects it. The uniformity of the H-stone screams of templates, of jigs, of a system of measurement and reproduction that allowed different workers, perhaps at different times, to produce components that were meant to fit together with machined interchangeability. This concept of interchangeable parts did not enter mainstream manufacturing until the Industrial Revolution in the 1800s. Yet here in the heart of the Andes, a culture we are told had only stone, bronze, and copper appears to have been practicing a form of it over 1,000 years ago. The H-blocks are not sculptures, they are components. And if they are components, then the logical, breathtaking question becomes, what were they designed to fit into this machine perfection leads directly to the second, even more baffling marvel: the seamless mortise and tenon joints. If the H-blocks are the standardized components, then these joints are the precision fasteners designed to lock the entire structure together. On many of the andesite and red sandstone blocks, you will find small, perfectly square or rectangular knobs, known as tenons, protruding from their surface. Opposite these on another stone is a corresponding cavity or mortise carved to receive it. This is the same basic principle used in fine woodworking, where a peg fits into a hole to create a strong, interlocking joint without nails or glue. The concept is simple, but the execution at Puma is anything but. These are not rough pegs hammered into crude holes. The tenons are geometrically perfect, with sharp, clean edges. The mortises are mirror images, carved to an exacting tolerance. When fitted together, the join was so flawless that not even the thinnest blade could be slipped between the stones. There was no need for mortar, clay, or any binding agent. The fit itself provided monolithic stability. Think of it like a master cabinet maker creating a dovetail joint, where the precision of the cut creates the strength. Now imagine scaling that up to ton blocks of volcanic rock and achieving that same hair's breadth accuracy. This reveals a profound understanding of structural engineering. The builders weren't just stacking stones, they were assembling a giant, three-dimensional stone puzzle, where every piece transferred weight and stress through these perfect, interlocking joints. This speaks of a level of planning that goes far beyond trial and error. It required foreknowledge of every block's final position, its relationship to its neighbors, and the precise dimensions needed to achieve that legendary, airtight fit. The joints are a silent testament to a blueprint, a grand design executed with a confidence that leaves no room for error. This precision becomes even more confounding when you feel the weight of the stone itself. The primary materials chosen by the builders were not just any rocks. They were andesite and an even more formidable stone called diorite. These are igneous rocks born from volcanic fire and pressure, and they possess a dense, crystalline structure filled with quartz. On the scale that measures a mineral's hardness, where talc is a 1 and diamond is a 10, these stones sit between a 6 and a 7. That number might not sound dramatic, but its practical implication is staggering. It means these stones are harder than steel. The copper tools available to the culture, and even early bronze alloys, would have been significantly softer. Trying to carve diorite with a copper chisel would be like trying to carve a brick with a stick of butter. The tool would simply deform and blunt against the unyielding surface. Conventional archaeological explanations point to a method of abrasion, using harder stones like quartzite to pound and grind, combined with sand and water to slowly wear away the material. This technique, known as pecking and grinding, can indeed shape hard stone over immense periods. But when we apply this theory to Puma, it begins to strain under the sheer scale of the task. We are not talking about slowly carving a single ceremonial bowl. We are talking about quarrying, transporting, and then precision machining hundreds of massive blocks, each requiring thousands of man-hours of relentless, grueling labor with ineffective tools. The theory struggles even more to explain the specific features we find. How does pecking and grinding with a round stone create a perfectly straight, razor-sharp interior corner on an H block? How does it produce the deep, clean, cylindrical holes drilled into some of the slabs? Holes that show no spiraling marks from a hand-powered drill, but instead appear smooth and uniform. The abrasive method is a theory of immense, slow force, but the artifacts at Puma speak of controlled, precise, and efficient removal of material. It is the difference between slowly sanding down a piece of wood to a rough shape and using a power saw to make a perfect, clean cut in a single pass. The mismatch between the presumed tools and the evidence left in the stone is a gap that whispers of a forgotten process, a lost technique that could work with hard stone not by brute force, but with a kind of knowing ease. These perfect joints and surfaces are only part of the story, for the third marvel pushes the mystery into an entirely different dimension of skill. Look closely at the broken and scattered stones, and you will find something that should not exist. Perfectly cylindrical holes bored straight into the unyielding andesite and diorite. Some are small, others wide enough to fit your fist into, but they all share one impossible characteristic. Their walls are smooth, uniform, and round to a degree that defies hand tools. Even more telling, inside a few of these holes, researchers have noted faint, consistent spiral grooves running along the interior surface. This is not the mark of a stone being pounded or ground away. This is the signature of a drill, specifically a tubular drill bit, a core drill that removes a cylinder of material as it spins. The presence of these spiral striations indicates a tool that was rotating with immense, steady force and advancing into the stone at a constant rate. Creating such a feature with a simple hand-powered bow drill on stone this hard is almost unthinkable. The friction would be catastrophic, the bit would wander, and the grooves would be irregular and shallow. These holes speak of a tool with substantial torque and a cutting tip harder than the rock itself. Beyond the holes, the stones reveal another layer of complexity. Some blocks feature intricate, recessed channels and perfectly square or rectangular pockets carved deep into their faces. These are not surface decorations, they are negative spaces removed with surgical precision. To create a deep, flat-bottomed pocket in granite-hard stone, using only a hammerstone would be like trying to hollow out a soup bowl from a slab of concrete using another rock. You would shatter the edges, leave a rough, uneven base, and likely crack the entire block in the process. The pockets at Puma have sharp, clean internal corners and consistent depth, as if the material was simply and cleanly scooped out. This points away from the slow, brutal method of abrasion and toward a technology that could remove material efficiently and with control. It suggests a process more akin to milling or routing. The combined evidence of the drill holes and the recessed channels paints a picture not of brute force, but of applied power. It implies tools that could spin, cut, and plane stone with a level of authority we do not associate with ancient South America. This technology, if it existed, represents a quantum leap. It is one thing to shape a stone with infinite patience. It is another to command it. The true scale of the mystery only becomes clear when you see the aftermath. Walk across the plateau of Puma today, and you are not walking through a ruin, you are walking through a battlefield. The ground is littered with the shattered components of a grand design, thousands of immense stone blocks tossed and scattered in a state of utter chaos. These are not stones that have gently settled over centuries of neglect. They look as if a giant, indifferent hand swept across a meticulously assembled model, scattering the pieces in a violent, instant rage. The heaviest of these blocks weigh well over 100 tons, the equivalent of 24 full-grown elephants. Yet they lie at unnatural angles, many of the finely machined H-blocks and interlocking pieces snapped apart, their perfect joints now separated by chasms of empty space. This is not decay. This is demolition on a titanic scale. This scene of colossal destruction is not a secondary detail, it is central to the entire enigma of Puma. The site forces us to ask two interconnected, haunting questions. First, how was this engineering marvel built? And second, what possessed the power to unbuild it so completely? The evidence written into the landscape points toward a sudden, catastrophic event. Some researchers studying the geology of the surrounding area have found signs of immense flooding, likely from the nearby lake, the vast inland sea that sits even higher in the Andes. Imagine a wall of water, fueled by a seismic shift or a colossal rainfall, surging across this high plateau with enough force to pluck ton stones from their fittings and dash them against one another. Couple that with the intense seismic activity native to the region, and you have a recipe for instantaneous, overwhelming ruin. The stones themselves tell this story, many of them bearing deep, parallel scratches as if dragged violently across the ground, a signature of powerful water action. This catastrophic context transforms our understanding of the site. It means the builders did not have the luxury of time to see their work slowly fade. Their achievement, born from such profound skill and planning, likely met a sudden and violent end. This realization makes the original accomplishment even more staggering, and its loss feels profoundly poignant. It hints at a high civilization that reached a technological and artistic peak, only to have its greatest testament shattered in what may have been a single, terrible day. The precision of the cuts and the chaos of the scatter field exist side by side, a permanent record of both brilliant creation and unimaginable destruction. The silence that followed that event is what we are left to decipher, a silence filled only by the wind and the unanswered questions locked in the stone. This mainstream perspective offers a grounded and human-centered explanation for the mystery. Archaeologists point to the culture, a sophisticated society that dominated the region for centuries, as the master builders behind Puma. Their timeline places its construction squarely within their period of influence, roughly from 500 to 1,000 years after the Common Era began. In this view, the tools were simple but effective, stone hammers made from even harder rock, copper and bronze chisels, and an abundance of gritty sand used as an abrasive. The method they propose was not one of speed but of immense collective patience. Imagine teams of workers, generation after generation, using a technique called pecking and grinding. They would strike a stone with a harder hammerstone to create a rough shape, then spend countless hours grinding the surface with sand and water, slowly wearing the rock down through sheer, persistent friction. To demonstrate this is possible, modern researchers have undertaken experimental archaeology, using these exact methods to recreate some of the simpler cuts and holes found on site. These experiments prove that with enough time and labor, stone can be shaped. The mainstream argument, therefore, is not about the impossibility of the task, but about the scale of the commitment. It asks us to reconsider our modern bias toward efficiency. For a culture with a deep spiritual connection to the site, where construction was a sacred act, the investment of thousands of lifetimes of labor was not an obstacle, it was the purpose. This perspective celebrates human ingenuity and social organization, suggesting they achieved this precision through meticulous planning, accumulated knowledge passed down through master craftsmen, and a society capable of mobilizing and sustaining a vast workforce for a communal vision. It transforms the site from a potential technological anomaly into one of humanity's greatest monuments to perseverance. The narrative is powerful. It tells us that with enough determination, community, and time, people can move mountains and carve them with a jeweler's precision. Yet, for all its compelling logic, this explanation leaves some observers standing before the stones with a persistent, quiet question. Does the sheer, machine perfection we see truly align with the slow, grinding process of hand tools? Or does it point to something else entirely? Respect for the mainstream view is essential. But so is looking directly at the evidence it must explain. The theory of stone hammers and endless grinding presents a series of logical hurdles when held up to the cold, hard reality of the stones themselves. First, consider the sheer scale of material. We are not discussing a few ornate pillars, but hundreds of massive blocks, each from distant mountains, transported across miles of rugged terrain, and then subjected to this immensely slow shaping process. The cumulative man-hours required stretch into the millions, demanding a society able to feed, house, and organize a veritable army of craftsmen for centuries. While they were undoubtedly capable, the logistical footprint of such an operation would be enormous. Yet, the archaeological record around Puma shows a curious absence of the expected supporting infrastructure. Where are the mountains of waste material, the countless broken hammerstones, the dedicated workshops for sharpening and resharpening tools that such a relentless, brute force campaign would inevitably produce? The site feels more like a finished assembly yard than a sprawling, messy factory floor. Then there is the question of the finish. Look at the surface of a perfectly planar andesite slab, or the interior of one of those sharp, 90-degree corners. The conventional method of pecking and grinding leaves a distinctive texture, a pitted or subtly undulating surface from the countless impacts of a hammerstone, even after final polishing. Yet many of the most precise surfaces at Puma lack this signature. They are smooth in a different way, a consistent, almost glassy flatness that seems to result from material being cleanly sheared away, not pounded into submission. This leads to the most perplexing challenge, the consistency of complex cuts. Take the repeating H-block pattern. Achieving one such block with hand tools is a monumental feat of skill. Achieving dozens, each a near-perfect mirror image of the others in both dimension and detail, moves the goalposts from skilled craftsmanship to standardized mass production. The margin for error across so many individual artisans, working over generations, would be immense. The uniformity we see suggests the use of a guide, a template, or a tool that could replicate the same cut with mechanical reliability, something a simple stone ball simply cannot provide. Finally, we must confront the factor of time. The primitive tool hypothesis asks us to accept a timeline where progress is measured in generations per block, where the grand vision of Puma would have taken many centuries to realize. This raises a profound question about cultural continuity. Could a society maintain the exact same architectural vision, the same precise engineering standards, and the same level of resource commitment over dozens of human lifetimes without deviation? It is not impossible, but it adds another layer of immense difficulty to an already staggering proposition. The stones, in their silent perfection, seem to tell a different story, one of conception and execution within a more compressed, confident. They speak of a technology that could match the ambition of the design, turning the visionary blueprint into reality not through slow, grinding endurance, but through applied and effective technique. This is not to dismiss the incredible ingenuity of ancient peoples, but to honestly acknowledge the gap between the tools we believe they had and the results that stand before us. The primitive tool hypothesis is a testament to human patience, but the stones of Puma whisper of something that looks remarkably like precision engineering. The finished stones present a monumental challenge, but it is the journey from quarry to site that truly defies belief. The nearest source of the distinctive andesite used at Puma lies over 10 kilometers away, a distance that must be measured not in miles but in sheer effort. Between the quarry and the high plateau lies a rugged, unforgiving landscape of steep inclines, rocky ground, and the ever-present thin air of the high Andes. To move a single 100-ton block under these conditions would be a staggering achievement for any ancient culture. Yet as far as we know, did not possess the wheel for transportation. They also lacked large draft animals like oxen or horses to provide pulling power. Every ounce of force required to move these megaliths would have had to come from human muscle, coordinated on a scale that is difficult to comprehend. The mainstream and most plausible explanation points to a combination of ingenuity and raw manpower. It envisions armies of workers using thick ropes woven from plant fibers, levering the stones onto a bed of smoothed log rollers. Teams would then pull the massive block forward, while others constantly rushed to move the logs from the back to the front, creating a slow, rolling pathway. Earthen ramps, built from compacted soil and rubble, might have been constructed to overcome steepest grades. This method is physically possible, and we have evidence of its use in other parts of the ancient world. But applying it here, at an altitude where every breath contains 30% less oxygen, transforms a difficult task into a physiological marathon. The workers would not only be fighting against friction and gravity, but against their own bodies, battling altitude sickness and exhaustion with every heave on the ropes. The logistics become a nightmare of numbers. How many people can physically fit around a 100-ton block to pull it? How do you coordinate hundreds, perhaps thousands, of individuals to pull in perfect unison without the stone veering off its path or crushing someone? Where do you house and feed this temporary city of laborers? The project management alone suggests a society with an almost military level of organization and a shared purpose powerful enough to motivate generations to undertake such a grueling, dangerous task. This theory of rollers and ramps is a testament to human cooperation, yet it still feels incomplete when you stand before the scattered stones. It explains the how in its most basic form, but it deepens the why. What vision was so compelling, what belief so unshakable, that it justified this immense cost in human energy? The transportation riddle does not diminish this accomplishment, it amplifies it, framing their work not just as artistry, but as an act of profound collective will. Yet for some, it also leaves a lingering whisper. Could there have been another way? A lost method of moving mass that made this Herculean task just a little less impossible. The silent testimony of the stones points toward a level of control that feels distinctly modern. This undeniable gap between the presumed tools and the actual results has given rise to a compelling alternative theory, one that dares to reimagine humanity's forgotten chapters. It is the idea of lost ancient high technology. Proponents of this view look at the machined surfaces, the perfect drill holes, and the standardized components, and they ask a simple, radical question. What if the explanation is not a mystery of immense patience, but a mystery of lost knowledge? What if the builders of Puma possessed tools and techniques far more advanced than the simple stone and copper implements found in the archaeological record? The theory suggests that to work diorite and andesite with such ease, they might have employed cutting tips made from materials harder than the stone itself, perhaps diamonds set into saw blades or drill bits. Other possibilities include methods that seem to border on science fiction, like sonic or vibrational tools that could resonate stone at a specific frequency, causing it to fracture along precise lines with minimal effort. There is even speculation about the use of a kind of ancient, man-made stone that could be poured into molds to create these perfect shapes, explaining the uniformity and lack of tool marks. This is not merely a claim about better chisels, it is a paradigm shift. It proposes that long before our recorded history, a sophisticated, perhaps even global, civilization achieved a technological peak. This advanced culture, according to the theory, possessed an understanding of materials, engineering, and energy that has since vanished from human memory, erased by a great cataclysm. A planetary event that shattered societies and reset the clock of progress. In this sweeping narrative, Puma is not an anomaly built by the with primitive means. Instead, it is a surviving relic, a fragment of that forgotten epoch. The people may have found these precisely crafted stones already scattered across their high plateau, repurposing them for their own sacred site, inheriting a mystery they themselves could not fully explain. The theory offers a powerful allure. It solves the precision problem by suggesting the tools were always adequate to the task, because the task was conceived with those tools in mind. It transforms Puma from a puzzling achievement into a profound clue, a piece of technological archaeology waiting for us to finally understand its language. This perspective does not diminish but it places them within a much deeper and more mysterious historical current, as inheritors of a legacy whose origins are lost to time. The notion of a lost human technology is one thing, but the stones of Puma have inspired theories that reach far beyond our world. When human explanation seems to strain against the evidence, the mind naturally searches for something greater, something other. This leads us to the most speculative interpretation of all, the idea that the knowledge behind this place did not originate on Earth. Could the precision we see be the result of extraterrestrial guidance, or perhaps divine intervention from a forgotten age of gods? This perspective, often explored in ancient astronaut theories, asks us to consider a radical possibility. What if the builders were not working from their own accumulated experience, but from instructions given to them? Proponents of this view highlight elements that feel inexplicably advanced for their time. The astronomical alignments some researchers attribute to the site's original layout, the sheer mathematical consistency of the blocks, and the almost supernatural skill required to execute such work are all presented not as human triumphs, but as potential signatures of an outside intelligence. The theory suggests that visitors, whether from the stars or a divine realm, provided the blueprint, the tools, or even the direct assistance to make this marvel a reality. For those who hold this view, Puma becomes less an archaeological site and more a landing pad for ideas from beyond our historical understanding. It is a testament not to what humanity could do alone, but to what it might have been shown how to do. While this idea exists firmly outside the boundaries of mainstream science and lacks any tangible evidence beyond the anomaly itself, its enduring popularity is deeply revealing. It speaks to the profound sense of awe the site commands. When something feels truly impossible within our established frameworks, the human imagination instinctively expands those frameworks, reaching for myth, for legend, for the stars. The very existence of such a theory underscores the core mystery. Puma is so baffling that it pushes rational explanation to its absolute limit, inviting speculation that ventures into the realm of the extraordinary. It forces a humbling question. Are we looking at the pinnacle of unknown human technology, Or are we looking at a message from something else entirely? A message we have not yet learned how to read. Look closer at the cut itself, at the very surface where the tool met the stone. Beyond the grand shapes and perfect angles lies a microscopic world of evidence, a landscape of tiny grooves and striations that may hold the final clue. Some researchers examining these surfaces under magnification report something startling. On certain flat plains, especially within the deep recessed channels, they observe long, perfectly parallel lines running in a single, unbroken direction. These are not the random, pitted scars left by pounding with a hammerstone. They are orderly, consistent, and straight, bearing a striking resemblance to the marks left by a modern industrial saw blade as it passes through material. Think of the fine, parallel lines you might see on a piece of lumber cut by a table saw, a signature of the individual abrasive particles on the blade's edge. The presence of such striations on volcanic andesite suggests a cutting motion, a back and forth or circular movement that dragged an abrasive material across the surface with immense, sustained force. This is a fundamentally different action than pounding or grinding. It implies a tool that was guided, not just wielded. Even more telling are the sharp, interior corners where two flat planes meet at a perfect 90 degrees. In conventional stonework, creating such a crisp internal angle with a hammer and chisel is nearly impossible without some chipping or rounding at the very vertex. Yet at Puma, these corners are often clean and sharp, as if the material was removed from both sides with such precision that they met in a flawless line. This points to a tool that could cut on more than one axis, something capable of milling out a precise pocket rather than just shaping an exterior face. So if these are indeed saw marks, the immediate practical question becomes almost overwhelming. What kind of blade could possibly achieve this? Andesite is filled with quartz crystals, and quartz is harder than steel. To cut it efficiently, the cutting edge of the saw would need to be made of something even harder. In our modern world, that material is diamond. Diamond-tipped blades are what we use today to cut through granite countertops and precisely shape hard stone. The idea that an ancient culture might have used diamond abrasives is not pure fantasy. Diamonds do exist in nature and were known to ancient cultures for their hardness. But mounting such abrasive particles onto a stable, rigid blade, and then driving that blade with enough consistent power and control to make long, straight cuts in multi-ton blocks, suggests a level of mechanical engineering that rewrites the history books. It implies a frame to hold the blade taut, a mechanism to move it, and a power source to drive it, whether human, animal, or even water-driven. This microscopic evidence transforms the debate. For mainstream archaeology, these striations might be explained as the result of a long, laborious process using a straight piece of wood or stone with sand and water, drawn back and forth like a saw over centuries. But for proponents of alternative history, these parallel lines are the literal smoking gun, the direct imprint of a lost technology. They see in these grooves not the slow grind of sand, but the confident, efficient pass of a tool that was equal to the task. This tiny, almost invisible detail on the stone's skin becomes a critical. It asks us to decide, are we seeing the patient scratch of primitive ingenuity or the clear, mechanical signature of a forgotten science? The answer depends entirely on what we believe was possible in the distant past. The precision of the cuts is only the beginning of the mystery. To truly grasp what the builders knew, you must look beyond the individual stones to the grand design they were meant to form. The interlocking H-blocks and seamless mortise and tenon joints were not merely artistic choices or displays of skill. They were a deliberate, brilliant solution to a fundamental problem. This high plateau is not a stable foundation. It is a land shaped by immense geological forces, prone to tremors and seismic shifts. The builders knew this. Their response was not to build a rigid, monolithic structure that would crack under stress. Instead, they designed a system that could breathe. By creating a complex network of interlocking stones, they engineered a degree of flexibility into the very skeleton of their creation. During an earthquake, a rigid wall will resist movement until it shatters. But a wall made of perfectly fitted, interlocking blocks can absorb and dissipate that energy. The stones would have been allowed to shift minutely, to settle and adjust, without losing their structural integrity. This is not primitive architecture, it is advanced seismic engineering. It reveals a profound, empirical understanding of physics, of how forces travel through materials and how to redirect that energy to prevent catastrophic failure. The builders were thinking like modern civil engineers, anticipating the challenges of their environment and inventing a resilient solution ahead of its time. This engineering genius extends to the most basic element of all, the flat surface. Why go to such extraordinary lengths to make a stone perfectly planar? The answer lies in the efficient distribution of weight. When one multi-ton block rests upon another, the contact point between them is critical. A rough, uneven surface creates points of intense pressure, like standing on a single Lego brick. Over time, under the immense load, the stone at these high-pressure points would begin to crush and crumble, leading to weakness and eventual collapse. But a flawlessly flat surface spreads the load evenly across the entire area of contact. The weight is distributed, the pressure is reduced, and the structure gains a stability that can endure for ages. The builders understood this principle of load-bearing intuitively. Their obsession with geometric perfection was not an aesthetic luxury, it was a structural necessity. Each crisp 90-degree angle ensured that forces were transferred vertically, down through the joints, rather than creating sideways thrust that could topple walls. This indicates a knowledge that goes far beyond trial and error. It points to a culture that had studied, perhaps over generations, how stone behaves under stress. They weren't just copying shapes, they were applying the laws of physics to create something eternal. The very stones themselves become a testament to a forgotten school of practical science, where artistry and engineering were inseparable. When you see those impossibly flat surfaces, you are not just looking at a demonstration of skill, you are looking at the cold, calculated mathematics of survival, carved in rock. But to truly weigh these extraordinary theories, we must first understand the people at the heart of the conventional story. The empire was not some primitive tribe struggling for survival on a barren plateau. They were, by any measure, a sophisticated and powerful civilization whose capabilities force us to take their potential as builders very seriously. Their mastery began not with stone, but with earth and water. In the harsh environment of the Altiplano, where frosts are common and the growing season short, they engineered a revolutionary agricultural system. They built vast networks of raised fields, known as, which were essentially long, rectangular planting beds surrounded by canals. This ingenious design regulated soil temperature, protected crops from frost, and provided a constant source of nutrient-rich silt and water. This agricultural genius allowed them to support a large, concentrated population, perhaps numbering in the tens of thousands, right there in the heart of the Andes. A society that can feed itself so effectively has the surplus energy and organized labor to pursue grand projects. Their social structure reflected this complexity with a stratified system of classes. From farmers and artisans to a powerful priestly and ruling elite, who likely directed the spiritual and architectural vision of the empire. Their influence stretched far across the region, with trade networks moving goods like obsidian, coca, and colorful feathers over hundreds of miles. And they were, undeniably, master builders in their own right. Just a short walk from Puma stands a massive stepped pyramid platform that once served as a sacred temple. It is a monumental feat of earth and stone construction, demonstrating their skill in moving and placing large blocks, and their deep understanding of ceremonial space and celestial alignment. This is the established, impressive context, so when we look at Puma, the mainstream position is clear and reasonable. This was simply the most ambitious project, the pinnacle of their architectural and engineering evolution. It represents the logical culmination of generations of accumulated knowledge, the work of master craftsmen pushing their traditional techniques to the absolute limit. In this view, the site is a testament to human potential within a known historical framework. Yet, even with this full picture of brilliance, a subtle but persistent question remains. Does Puma truly feel like a natural progression from their other works, or does it stand apart as something categorically different? The is monumental, but its stonework is of a different character, larger, more robust blocks fitted with clay mortar. The precision at Puma is of another order entirely, a shift not just in scale, but in fundamental technique. This is the core of the enduring mystery. If this was their ultimate achievement, why does its technological signature appear so abruptly? And why was it never replicated again in the archaeological record of the Andes? The alternative perspective asks us to consider a more complex inheritance. Could they, at the height of their power, have discovered the scattered, pre-cut stones of an even older, vanished culture already lying on that windswept plain? Might they have revered these impossibly perfect components as gifts from the gods or relics of a primordial age, and incorporated them into their own sacred complex? Building their walls around a mystery they themselves could not create, this possibility does not diminish but reframes them. It suggests they were not just inventors, but also curators, inheriting a legacy of stone that whispered of a lost world, a puzzle they honored but perhaps could never fully solve. The stones themselves are oriented with a purpose that reaches beyond the earth. Puma is not a random collection of blocks, it is a deliberate arrangement, and its grand platform is aligned with the four cardinal directions, north, south, east, and west, with an accuracy that feels intentional. This is not a rough approximation. The precision of this orientation suggests the builders possessed a sophisticated method for surveying the land and establishing a true baseline. A skill that requires a deep understanding of geometry and the movement of the sun. Some researchers looking at the layout have gone further, proposing that specific walls might have been aligned with significant stars, the solstices, or the equinoxes. While these more specific stellar alignments are debated, the foundational cardinal alignment is not. It is a fact etched into the very foundation of the site. This tells us something profound about the builder's mindset. They were not just constructing a building, they were anchoring their creation to the cosmos. They were mapping the heavens onto the earth. This practice of celestial alignment is a hallmark of advanced ancient cultures worldwide, from the pyramids of Giza to the great observatories of. It speaks of a people who saw their world as intimately connected to a larger, orderly universe. To achieve such alignment requires more than just watching the sky. It demands meticulous observation recorded over generations, the development of a consistent calendar to mark the cyclical events, and the application of mathematics to translate those celestial observations into precise angles on the ground. This is not the work of casual stargazers. It is the work of astronomer priests, of keepers of knowledge who could track time in scales far beyond a human lifetime. So we are presented with a compelling parallel. The same culture that could measure the slow drift of stars and the precise turning points of the sun with such care, that could embed that cosmic knowledge into the orientation of their most sacred site, is the culture we are asked to believe shaped these stones with nothing but simple tools and brute force. The two capabilities seem to stem from the same root, a disciplined, mathematical mind. If they possessed the intellectual rigor to master the heavens, is it truly so difficult to believe they could master the earth? The astronomical alignment transforms Puma from a potential workshop into a temple of integrated knowledge. It suggests the precision in the stonework was not merely functional, but symbolic. Each perfectly flat surface, each sharp angle, each interlocking joint may have been a physical echo of the perfect, mathematical order they observed in the night sky. The site becomes a mirror, a terrestrial reflection of a perceived celestial harmony. Building such a mirror would require more than just skilled laborers. It would require a grand, unwavering vision, planned down to the smallest detail before the first stone was ever. This level of holistic planning, where architecture, astronomy, and engineering converge, points to a civilization operating at a peak of integrated understanding. The stones are silent, but their alignment speaks volumes, whispering of a blueprint drawn not just on parchment, but against the backdrop of the stars. Yet this architectural language of impossible precision is spoken in more than one ancient tongue. Puma stands as a profound mystery, but it does not stand alone. Scattered across the globe are other sites that echo its silent, megalithic challenge. High in the Peruvian Andes, the fortress of displays walls built from colossal limestone blocks, some weighing over 100 tons. These stones are not rectangular, but polygonal, fitting together in a dizzying, irregular jigsaw puzzle. The joins between them are so meticulously crafted that, like at Puma, you cannot slip a piece of paper between the seams. The curves and angles interlock with a complexity that seems to defy any simple method of hand-fitting. Then travel across the world to the Valley of Lebanon, to the podium of the Roman temple at Baalbek. Here, resting in a quarry, lies the famed stone of the pregnant woman, a single block of limestone estimated to weigh well over 1,000 tons. Even more staggering are the 3 blocks already in place at the temple foundation, each weighing around 800 tons, positioned with a precision that leaves modern engineers in awe. How were these behemoths moved and lifted into place? Further south, beneath the sands of Egypt at the of Saqqara, lies another category of mystery. Within a long, subterranean tunnel rest 24 enormous stone boxes, each carved from a single piece of granite or diorite. The boxes, some weighing up to 100 tons, have interiors so smooth, with corners so sharp and surfaces so perfectly flat, that they achieve a level of finish comparable to modern precision machining. The lid of one box alone weighs an estimated 30 tons, yet it was engineered to fit its base with a seal so tight it was likely airtight. What connects these distant sites, separated by oceans and cultures? It is not a shared artistic style, but a shared technological signature. We see a recurring theme of megalithic scale combined with micro-level precision, of moving the immovable and shaping the unshakable with a confidence that bypasses what we consider primitive methods. This pattern suggests something deeper than coincidence. It points to the possibility of a lost architectural science, a body of knowledge about stone, physics, and engineering that was either discovered independently by multiple cultures at the peak of their ingenuity, or perhaps diffused from a common, older source now lost to time. The comparison does not give us easy answers, but it powerfully reframes the question. Puma is no longer just a Bolivian anomaly, it is a single piece in a global puzzle. Each site is a clue, and together they ask us to reconsider a fundamental narrative. Was human technological progress a slow, linear climb, or could there have been peaks of achievement, forgotten valleys of knowledge, whose echoes we only now find carved in stone? The gap between simple tools and perfect stonework invites us to consider a more elegant physics. If pounding and grinding seem too crude for the task, what natural forces could the builders have commanded with enough finesse to carve diorite? Water, ever present in the high Andes from lake and seasonal rains, may have been far more than just a passive abrasive mixed with sand. Some researchers propose a radical leap, suggesting they could have harnessed water under immense pressure. Imagine a narrow, reinforced tube, perhaps made of hollowed-out stone or resilient leather, channeling water from a high-altitude source. By focusing this flow into a concentrated, high-pressure jet, you create a natural water saw. We use this principle today with industrial water jets that cut through steel and stone by blasting a mixture of water and abrasive garnet. Could an ancient version, using the natural hydraulic head pressure from the nearby lake or a constructed reservoir, have provided the sustained, precise force needed to slice through andesite? It is a compelling thought, turning the landscape itself into a power tool. This idea extends to even more speculative techniques involving chemistry. Certain plants native to the region contain acidic compounds. Hypothetically, if applied to the crystalline structure of the stone, such agents might have temporarily softened the surface layer, making it easier to work with simple tools before it rehardened. While no direct evidence for this exists, it illustrates the kind of outside-the-box thinking the site demands, searching for a method that is both sophisticated and derived entirely from the local environment. Another natural force readily available on that sun-drenched plateau is thermal energy. The concept of thermal shock is simple: heat a rock rapidly and then cool it suddenly, and the stress will cause it to fracture. But to control that fracture, to guide it along a precise straight line, requires immense skill. Some hypotheses suggest the builders could have used polished metal or stone reflectors to focus sunlight into a searing, narrow beam, essentially creating a solar laser. They might have traced a line of intense heat along the stone's surface, then rapidly cooled it with water, causing the rock to split cleanly along that weakened, superheated path. This is not magic, it is applied thermodynamics, a brutal yet potentially precise technology that uses nothing but the sun, water, and a deep understanding of material science. These theories, while speculative and lacking in archaeological proof, serve a vital purpose. They are not wild guesses, but logical attempts to bridge the chasm we see. They propose that this genius may not have been in inventing complex machinery, but in achieving a profound symbiosis with their world. Their advanced technology might not have been made of gears and steel, but of water, light, and plant knowledge, a physics of place that turned the elements of their harsh environment into precise instruments. This perspective reframes the builders from laborers with simple tools into master physicists and engineers, who listened to the whispers of stone and answered with the voice of the river and the fire of the sun. The debate over precision inevitably leads to a more fundamental question: when was this all built? The established archaeological timeline, based on radiocarbon dating of organic materials found in the soil layers around the site, points firmly to a period around 500 to 600 years after the Common Era began. This places Puma squarely within the golden age of the empire, a logical and comfortable fit within our understanding of Andean history. Yet, for a growing number of researchers looking at the stones themselves, this date feels like a profound mismatch. They argue the timeline is not just slightly off, but catastrophically wrong. Their evidence comes not from charcoal or bones, but from the geology of the site and the very fabric of the megaliths. They point to the deep alluvial silt layers that blanket parts of the complex, sediments that suggest immense, ancient flooding events. More compelling to them are the patterns of weathering on the stones. The intricate, machined surfaces show a type of erosion that appears more consistent with water damage over than with wind and sand over centuries. Some blocks are partially buried in a way that suggests they were already ancient ruins when the culture first arrived. This alternative assessment leads to a staggering conclusion that Puma could be a relic of a far more distant past, possibly constructed over 10,000 years ago. A time when mainstream history tells us human societies were nomadic hunters, not builders of precision-engineered stone complexes. The implications of this redating are seismic. If true, it would not just shift a date in a textbook, it would tear a hole in the conventional narrative of human progress. It would mean a sophisticated culture, capable of advanced stoneworking and seismic engineering, existed and then vanished long before the rise of Mesopotamia or ancient Egypt. This civilization would have flourished and then been lost in the turbulent wake of the last ice age, its memory erased by rising waters and climatic chaos. The dating controversy is not an academic footnote, it is the core of the mystery. Who gets the credit? Was this the crowning achievement of the known, or is it the legacy of a forgotten predecessor, a ghost culture whose name we may never know? The answer determines everything, reshaping our view of technological possibility and the true depth of human history. It forces us to ask, are we looking at the peak of a known civilization, or the scattered wreckage of a lost world? Perhaps the most profound mystery of Puma is not how the stones were cut, but why they were cut this way. The staggering precision, the obsessive repetition of the H-block pattern, the deep, clean channels, all of it suggests a purpose that transcends simple architecture. What if these forms are not just functional but symbolic? What if the stones themselves are a text, a language carved in andesite, waiting to be read? This perspective asks us to shift our gaze from the engineering to the intention, to consider that every perfect angle and groove might encode a meaning far deeper than structural integrity. The repeating H-shape, for instance, is so uniform, so deliberately replicated across dozens of blocks, that it feels less like a random architectural flourish and more like a glyph, a standardized symbol. In the worldview of many ancient cultures, repeating geometric patterns were never merely decorative. They often represented fundamental cosmic principles, the duality of earth and sky, the interconnection of all things, or the cyclical nature of time. Could the H-block be a physical manifestation of such a concept, a three-dimensional ideogram meant to be understood by touching, by seeing, by walking around? Some researchers looking at the intricate channels and recessed pockets see more than just clever joinery. They see potential schematics. The patterns could be diagrammatic representations of tools, of machines, or of energy pathways that held significance in a lost technological or spiritual system. Imagine finding a complex circuit board from a future civilization, its purpose unknown. You could analyze the material, marvel at the precision, but without understanding the language of its design, its true function remains a mystery. Puma may present a similar challenge. We are analyzing the hardware with awe, but we are completely illiterate to the software, the symbolic operating system that gave these shapes their true power and meaning for the people who created them. This idea transforms the site from a ruined building into a philosophical artifact. It suggests the builders were not just engineers, but philosopher-scientists, for whom precision was a spiritual discipline. The act of achieving geometric perfection in stone might have been a way to mirror the perceived perfection of the cosmos, to create a sacred space that was in literal physical harmony with universal order. In this light, the airtight joints were not just about seismic stability, they were about creating a seamless whole, a microcosm without flaw. The site becomes a meditation on the relationship between humanity, the earth, and the heavens, expressed not in words, but in angles and planes. To walk among these stones, then, is not just to witness a feat of construction. It is to stand in the presence of a silent, stone-bound library, whose volumes are written in a language of form we have only begun to imagine. The true message of Puma may not be about how they built it, but what they were trying to say. These enormous slabs present a fourth, deceptively simple marvel, the perfectly flat surface plane. It is one thing to see a precise cut or a sharp corner, but to stand before a single piece of andesite that stretches out like a vast, dark mirror. Its surface unbroken by any ripple or dip across its entire length is to witness a different kind of impossibility. These are not just flat stones, they are geometrically ideal planes carved into one of the hardest materials on Earth. When multiple such slabs were placed side by side, their edges meeting with that legendary airtight joint, they would have formed seamless walls or floors of almost supernatural smoothness. In the modern world, we achieve this level of flatness with machines called surface grinders or lapping plates, tools that use a perfectly flat reference surface and abrasive compounds to slowly, methodically wear down a material until no high points remain. The process is meticulous and machine-dependent. To accomplish the same feat on a multi-ton scale with primitive tools defies the physics of handwork. Think of trying to sand a wooden tabletop perfectly flat using only your palm and a piece of sandpaper. No matter how long you work, your own uneven pressure will inevitably create valleys and hills. Now imagine that tabletop is made of solid granite and the sandpaper is a piece of softer stone. The challenge becomes exponentially absurd. This is the core of the flat plane puzzle. It requires two things that are incredibly difficult to achieve without advanced tools: a consistent reference standard and a method to apply removal force evenly across every single square inch. The reference is key. How did the builders know when the surface was truly flat? They must have employed a master reference, perhaps a massive stone or a system of water levels that allowed them to check their work against an unchanging standard. Then they needed a technique that could touch every part of the surface with equal pressure. The slow pecking and grinding method, reliant on individual hammer strikes, is terrible at this, as each blow creates a tiny crater, making consistent flatness almost impossible to achieve over a large area. The flawless planes we see suggest a different approach, something that could skim material off the surface in a sweeping, controlled motion, like a giant carpenter's plane or a grinding wheel that passed over the entire slab. This speaks to a process that was systematic and repeatable. It points to a quality control protocol, where each finished block was checked against the master standard and corrected until it met an exacting tolerance. This is not the mark of individual artisans working in isolation. It is the hallmark of standardized, almost industrialized production. It implies a workflow where the goal was not just to make a block, but to make a block that was interchangeable with any other, a component in a grand design where perfection was the minimum requirement. The flat surface, in its silent, imposing simplicity, may be the most compelling argument of all, a stone testament to a culture that did not just build with rock. but commanded it with the calm assurance of a master physicist. The true marvel of Puma may not be in the stone alone, but in the people who moved it. Behind every impossibly flat surface and interlocking joint lies a social machine of breathtaking complexity. Constructing this site, no matter the tools, demanded the unified effort of an entire civilization. It required a master workforce, a coordinated army of thousands not for a season, but for generations. This level of organization implies a society with a powerful, stable central authority, a ruling class or priestly elite with a vision so compelling it could command the labor of a nation. They were not just building a temple, they were marshaling the very lifeblood of their culture toward a single, monumental goal. Think of the logistics alone. Before a single stone could be cut, the society had to solve the most basic human needs on a colossal scale. They needed to feed the workers. This meant agricultural systems, like the ingenious raised fields around lake, had to produce a massive and reliable surplus, far beyond what the farmers themselves required. They needed to house the laborers, creating temporary cities or permanent settlements near the work site. They needed to supply the project, establishing reliable trade networks for materials like abrasive sand, tough rope fibers, and specialized tools. And above all, they needed to coordinate. This was a symphony of human effort, requiring architects to design, foremen to direct, to extract, transporters to move, and master carvers to execute the final precision work. Each group had to understand their role in a process that might outlast their own lifetime. This speaks of a shared cultural narrative, a story so powerful that a person would dedicate their life to a project they might never see completed, trusting that their children and their children's children would carry the vision forward. The social structure needed to sustain this was, in itself, a sophisticated technology. It was a technology of belief, of hierarchy, of distributed knowledge, and of communal purpose. When we look at the scattered stones, we are therefore seeing two separate but intertwined wonders. One is the physical artifact, the precision-cut andesite. The other, invisible but just as real, is the social artifact, the unprecedented human cooperation that made it possible. This perspective gently shifts the mystery. It asks us to marvel not only at the how of the cuts, but at the why that could motivate such a sustained, titanic effort. What belief system, what understanding of the cosmos or their place within it, was so urgent that it demanded the creation of a gateway this perfect? The stones are silent on this point, but their very existence is a thunderous answer. They stand as permanent proof that this culture achieved something far greater than the sum of its individual members. They organized not just to survive, but to create a legacy in stone, a testament to what humanity can achieve when a shared vision aligns the will of thousands across the centuries. That, in its own way, is a precision every bit as remarkable as the joints that held their walls together. The stones conceal a geometry that moves beyond the simple perfection of the flat plane. Look at a broken fragment, and you may find an edge that is not a crisp 90 degrees, but a subtle, sloping bevel. Another block reveals a long channel, not just carved into its surface, but carved at a precise, consistent angle to that surface, creating a complex trough. This is the fifth marvel, the world of compound angles and intersecting channels. We are no longer looking at basic cubes or rectangles. These are sophisticated, three-dimensional shapes, where multiple planes meet not at simple right angles, but at calculated, often acute, intersections. To visualize this, think of the most intricate piece of a wooden puzzle, where the interlocking tabs are not straight pegs, but angled wedges, designed to slide together in one specific orientation. Now imagine carving that shape, with all its precise slopes and internal hollows, out of a solid block of granite-hard andesite, using only a hammerstone and sand. The mind recoils at the sheer improbability. A stonemason working freehand, by eye and feel, could never achieve such consistent compound angles across dozens of separate blocks. The tiniest error in one angle would throw off the entire assembly, preventing the legendary airtight fit. This level of complexity is the smoking gun for a guided process. It screams for the use of jigs, templates, or physical guides. A jig is a tool that holds the workpiece and guides the cutting tool along a predetermined path. In a modern workshop, you use a jig to ensure every cut on 100 pieces of wood is identical. The presence of these compound angles at Puma strongly implies the ancient builders used a similar principle. They likely created a master template, perhaps from wood or softer stone, that embodied the exact three-dimensional form they desired. This template would then be used to transfer that complex shape onto the raw andesite block, and more importantly, to guide whatever cutting tool they employed to ensure every pass, every angle, was replicated with flawless accuracy. This transforms our understanding of their workflow. It means the project began not at the quarry, but in the design phase. Someone or some group first conceived of these intricate, interlocking shapes. They drafted them, likely in full 3 dimensions, understanding how each angled face would meet its neighbor, how each channel would align to carry water or perhaps something else. This was a premeditated, mathematical design process. They solved the spatial puzzles on parchment or in models long before a single blow was struck on stone. Then in the fabrication phase, they possessed the technical means, the guides, the controlled tools, to faithfully reproduce that intricate digital blueprint in the most analog material imaginable. The compound angles are not an artistic afterthought. They are the literal signature of a master plan, a plan so detailed and so confidently executed that it turned a vision of impossible geometry into enduring. Unforgiving stone, the stones of Puma hold a geological clock within their very skin. A closer look reveals a puzzling contradiction that cuts to the heart of the dating debate. On one hand, you have those breathtakingly sharp edges and pristine, machine-like surfaces. On the other, you find blocks that appear ancient beyond measure, their corners rounded and softened, their faces by deep, time-worn pitting. This is the Weathering Anomaly, and it speaks in a slow, patient language of rain, wind, and elemental force. The erosion we see on the most worn stones is not superficial. It is a profound transformation, the kind that geologists associate with exposure over many thousands of years, not the mere centuries suggested by the conventional timeline. Imagine a granite mountain peak, smoothed over eons by relentless weather. Now imagine that same degree of softening on a meticulously carved architectural block. The two images, the sharp cut and the rounded form, seem to tell two different stories of age, yet they exist side by side at the same site. How can a block be both impossibly precise and impossibly old? One compelling explanation is that the weathering happened after the precision work was completed, but under conditions of extreme violence. If the site was struck by a colossal flood from lake, as some evidence suggests, the stones would have been submerged and then scoured by abrasive sediments for an extended period. This could have accelerated erosion dramatically, rounding edges and carving new channels in a relatively shorter, though still immense, span of time. The water's force could also explain why some blocks are deeply weathered, while adjacent ones retain sharper features, depending on their position in the chaotic scatter field. Yet for other observers, the weathering pattern points to a more radical possibility. What if the stones were already ancient when the culture rose to power? In this view, the deep erosion is a sign of great antiquity, suggesting the blocks were crafted and then left exposed to the elements before being incorporated into the complex. The builders in this scenario would have been inheritors, not originators. They might have found these mysterious, finely crafted megaliths scattered across their sacred plain, revered them as gifts from the gods or works of a forgotten people, and built their own structures around them. This would explain the stark contrast in weathering, some stones bearing the marks of an age far older than the culture that ultimately used them. The geological voice of the stones thus adds a crucial, physical layer to the mystery. It asks us to listen not just to the shape of the cuts, but to the story written by time upon the surface. Are we seeing a single, catastrophic event that aged the stones prematurely, or are we looking at two distinct chapters of history, separated by a vast and silent gap in time? The weathering does not give us a simple answer, but it firmly insists that the true timeline of Puma is written in a language far slower and more patient than our own. The gap between theory and stone is a space that modern hands have tried to fill. In recent years, driven by a shared fascination, groups of dedicated researchers and skilled stonemasons have embarked on a profound challenge. To recreate the precision of Puma using only the tools we believe were available. They set up workshops, gathered teams, and armed themselves with stone hammers, copper chisels, and abrasive sand. Their goal was not to prove impossibility, but to explore the boundaries of the possible. What they have learned is both illuminating and deeply sobering. Through immense effort, they can indeed shape hard stone. They can, over weeks and months of relentless pecking and grinding, create a flat surface or carve a shallow channel. They can, with a bow drill and endless patience, bore a hole into granite. These experiments prove a critical point: the individual actions are within human capability. The process works. Yet, as the replicas take shape, a clear and telling divergence emerges. The surfaces they create, while impressive, bear the unmistakable signature of the method. They show the subtle, undulating texture of countless hammerstone impacts, a surface that is flat to the eye but not geometrically perfect to the touch. The edges of their cuts are often slightly rounded, lacking the razor-sharp, crisp interior corners found on the ancient blocks. The holes they drill, while functional, show the irregular, wandering spirals of a hand-powered tool struggling against an unyielding material. Their work is a testament to human endurance, but it looks handmade. The originals at Puma do not. This difference is not a critique of the modern craftsman, it is the core of the data. The experiments reveal a staggering efficiency gap. To produce just one small replica block with these methods requires a small team working for an impractical length of time. When you scale that effort up to the hundreds of massive, complex blocks at the actual site, the cumulative man-hours balloon into a figure that challenges the very fabric of a sustainable society. The modern attempts show what can be done with infinite time and focused labor. But Puma itself presents evidence of something else, a process that achieved not just the result, but achieved it with a level of finish, consistency, and scale that suggests a different relationship with time altogether. These valuable experiments hold up a mirror, and in the reflection, we see not our failure to replicate, but the original builder's mysterious success. They highlight the chasm between proving a technique is physically possible and demonstrating that it was the technique actually used. The stones in Bolivia quietly ask us, if this was how it was done, where is the evidence of the millions of broken tools, the mountains of waste, the sprawling workshop city that such a grueling, multi-generational project would demand? The silence is as telling as the precision itself. Beyond the silent geometry lies a potential hidden layer, a dimension of experience we can only hear in our imagination. The stones may have been designed not just to be seen, but to be heard. This is the acoustic properties hypothesis, a less explored but deeply intriguing idea that asks us to listen to Puma. Look again at those deep, clean channels, the precisely carved recesses, and the hollows within the H blocks. What if their purpose was not merely structural or symbolic, but acoustic? Could this entire complex have been a kind of instrument, or a chamber designed to manipulate sound? Some researchers speculate that the site's layout and the specific shapes of its components might have been engineered to amplify certain frequencies, create echoes, or even produce standing waves of sound during ceremonies. The thought is captivating. It transforms the site from a static monument into a dynamic space where ritual and resonance intertwined. Where chants or drumbeats could have been shaped by the stone itself into something otherworldly. This idea extends beyond ceremony into the realm of the practical, and here it ventures into truly speculative territory. Could sound itself have been a tool? There are legends and scattered modern experiments exploring the concept of using resonant frequencies to affect solid matter. The principle is that every object has a natural frequency at which it vibrates most easily. If you match that frequency with enough energy, you can induce powerful vibrations within the material. In theory, a sustained, precise sonic frequency directed at a block of andesite could, potentially, cause internal stresses that might help fracture or shape it along desired lines. It is a concept that feels almost like science fiction, using vibration as a chisel. While there is no direct evidence this technology was used at Puma, the hypothesis serves a vital purpose. It connects this isolated Andean plateau to a whispered thread running through other ancient marvels. From the echoing chambers within the Great Pyramid to the strange sonic properties of sites like Malta's hypogeum, there are hints that ancient builders understood and harnessed sound in profound ways. At Puma, the very precision that defines the stonework could be a byproduct of a technology rooted in vibration, a process where controlled resonance did the work that we assume required brute force. This perspective does not ask us to believe in magic, but in a lost physics. It suggests the builders may have possessed an intuitive or developed understanding of wave mechanics, seeing sound not just as noise, but as a tangible force that could be directed. To stand among the scattered stones with this idea in mind is to experience the site differently. You are no longer just looking at a puzzle of form, but listening for a lost harmony, a frequency that once might have made the very mountains hum in tune with human intention. It is a reminder that our search for answers might be limited by our own senses, that the true key to the mystery could lie in a dimension of energy that has long since fallen silent. This conceptual leap from artistry to system is the sixth marvel of Puma, the standardization of components. When you look across the scatter field, you do not see a collection of unique, hand-carved sculptures. You see repetition, a library of identical forms. The H blocks are the most obvious example, each one a near-perfect copy of the others in size, proportion, and intricate detailing. This is not the work of individual artists expressing personal vision. It is the output of a process, a deliberate and controlled method of production. What we are witnessing is modular construction on a megalithic scale. Imagine a modern factory producing prefabricated wall panels or steel beams for a skyscraper. Each piece is manufactured off-site to exact specifications, then shipped to the construction site to be slotted into place. This system is efficient, reliable, and allows for rapid assembly. Puma suggests its builders operated on a strikingly similar principle. The H blocks, the lintels, the slabs with their mortise holes, these were all prefabricated components. They were likely shaped and finished at a dedicated workshop, perhaps near the quarry, where conditions and tools could be optimized for mass production. Then, these finished pieces were transported to the high plateau for final assembly. This modular approach solves numerous practical problems. It allows different teams to work simultaneously, quarrying, shaping, and assembling. It ensures that every part will fit with its neighbor because they were all made to the same master template. It turns the chaotic, unpredictable process of monumental construction into a predictable, almost logistical operation. But to achieve this, the builders needed something far more advanced than sharp tools. They needed a rigid system of measurement, a consistent unit, like an ancient inch or centimeter, that every craftsman understood and used without deviation. They needed quality control, a way to check each finished block against a standard and reject it if it was even slightly out of tolerance. And above all, they needed a grand, comprehensive plan. Someone had to design the entire complex down to the last detail, understanding how each standardized piece would relate to every other, long before the first stone was cut. This is the profound implication of standardization. It represents a shift in mindset. The builders of Puma were not just master stonemasons, they were systems engineers. They were thinking in terms of processes, tolerances, and interchangeable parts. This conceptual framework feels unmistakably modern, a glimpse of an industrial logic preserved in stone, waiting for us to recognize its quiet, revolutionary message. This profound silence in the stone is mirrored by a profound silence in history. While the Egyptians left us hieroglyphs and the Mesopotamians cuneiform, the left no deciphered written language that can tell us the story of Puma. We have stunning iconography, powerful symbols carved on monoliths and pottery, depicting deities and cosmic visions. But we have no manual, no chronicle, no inscribed tablet that says, "This is how we cut andesite. This is a linguistic and epigraphic dead end." The builders did not write down their methods, at least not in a way we can yet understand. This absence forces us into the role of forensic archaeologists. We are left with a crime scene of sorts, a collection of physical evidence scattered across a high plateau, and we must reconstruct the entire process, motive, and capability from the clues left behind. The stones must speak for themselves because their creators chose not to. This silence is not a minor detail, it is a huge, echoing part of the mystery. It begs two haunting questions. First, were the techniques so commonplace, so integrated into their daily craft, that writing them down seemed as unnecessary as writing a manual on how to breathe? In a society where this knowledge was passed from master to apprentice over generations, the idea of recording it might never have occurred to them. The second possibility is far more intriguing. What if this knowledge was not commonplace, but incredibly rare? What if the methods for achieving such precision were considered sacred, a form of priestly or royal technology guarded as a profound secret? In this scenario, the knowledge would have been orally transmitted only to a select, initiated few. This creates a fragile chain of wisdom, a chain that can be permanently broken by a single catastrophic event, a conflict, or the passing of the last keeper of the secret. The techniques would vanish not because they were impossible, but because the living library that contained them was lost. This lack of a written explanation does more than just frustrate modern researchers. It fundamentally changes the nature of our inquiry. It amplifies our total reliance on the stones themselves. Every striation, every angle, every subtle weathering pattern becomes a word in this silent language. We are forced to become close readers of geology and geometry, searching for the grammar of construction in the shape of a channel and the texture of a cut. It means that any theory, from the mainstream to the speculative, must ultimately be judged not against a historical text, but against the cold, hard, and unforgiving testimony of the andesite. The stones are the only witness, and they do not lie, but their testimony is written in a dialect of physics we are still struggling to translate. The silent stonework of Puma holds one more clue, a subtle but telling signature of a different material. On certain blocks, you will find narrow, T-shaped channels carved into the surface. These are not random scratches or decorative lines. Their shape is precise, with a wider opening at the bottom of the groove, creating a perfect dovetail or inverted T profile. This specific geometry is not an accident of erosion. It is a design feature, and its purpose becomes clear when you consider how it would be used. This is the seventh marvel, the countersunk clamp. A metal clamp, likely forged from copper or a copper alloy, would be fashioned to match this unique T-shape. The wider head of the clamp would slide into the wider cavity at the base of the channel. Once in place, the clamp would be locked in, unable to be pulled straight out. It would sit flush with the surface of the stone, its metal body seated securely within the rock itself. The intention is unmistakable. These grooves were engineered to receive and hold metal fittings. While no large clamps have been found still in place at the site, a crucial piece of evidence was discovered within some of these very channels. Researchers have documented the presence of small, thin fragments of copper and sometimes silver embedded in the grooves. This is not a random deposit. It is the residual trace, the metallic fingerprint, left behind. It strongly suggests that metal was indeed used here, not as a decorative element, but as an integral part of the assembly process. So what was the purpose of these hidden metal bonds? One compelling theory is structural reinforcement. Imagine two massive stone blocks fitted together with that legendary airtight joint. A seismic tremor, however slight, could create a tiny shift. Metal clamps, set into adjoining blocks and linked together, would act like internal staples, holding the stones in alignment and preventing any creeping movement over centuries. They would add a flexible strength to the rigid stone, a hidden skeleton of metal within the monument. Another possibility is that the clamps served as alignment guides during construction. Pouring molten metal into the prepared channels of two adjoining stones would create a permanent, custom-fit bond as it cooled and. This technique, known as metal strapping, is seen in other ancient monumental cultures, like the Incas at sites such as. The process itself is sophisticated. It requires forethought to carve the channels, the metallurgical knowledge to smelt and pour the metal, and an understanding of how the different materials, stone and metal, would interact as they cooled and contracted. This points to a hybrid material technology. The builders of Puma were not just masters of stone. They were practical engineers who understood the properties of multiple materials and combined them to solve complex problems. They created a composite architecture where the timeless strength of andesite was married to the tensile reliability of metal. This small, almost overlooked detail, the T-shaped groove with its metallic residue, opens a window into a more nuanced reality. It shows us a culture thinking several steps ahead, anticipating stresses we can barely perceive, and quietly locking their legacy together with a strength that was meant to last for the ages. But what if the stones themselves are not what they seem? The most radical reinterpretation of all challenges a fundamental assumption that these blocks were carved from solid rock. Instead, it proposes they were poured. This is the theory, a hypothesis that dares to reimagine the very substance of Puma. It suggests the builders possessed not a lost machining technology, but a lost chemistry. They may have mastered the art of creating artificial stone, a kind of ancient, high-performance concrete. In this view, the andesite and red sandstone were not and shaped, but engineered and cast. The process would have involved gathering the local, naturally occurring materials, clay, limestone, silica, and the distinctive red mineral deposits. Through a chemical process, perhaps using plant-based acidic solutions as catalysts, they could have broken down these materials at a molecular level. This activated slurry could then be poured into precisely crafted wooden or stone molds. Once it's set, the result would be a man-made stone, indistinguishable from natural rock to the untrained eye, but formed into any shape the mold could hold. This single idea could elegantly solve multiple puzzles at once. The breathtaking precision and flawless repetition of the H blocks, that is simply the perfection of the mold, replicated over and over. The complex compound angles and deep, clean channels, those are the negative spaces of the filled with liquid stone that hardened into exact copies. The seeming absence of traditional tool marks on the smoothest surfaces. There never were any because the surface is the mold's interior, a skin formed by contact, not by cutting. Proponents of this theory point to subtle clues within the stone's composition. Some samples analyzed have shown traces of organic materials, fibers or compounds that seem out of place in a purely volcanic rock. These, they argue, could be the remnants of the binding agents or the chemical accelerants used in the mixture. Furthermore, the consistency of the material from block to block, its uniform density and color, could be seen as evidence of a controlled recipe, a batch process, rather than the natural variation found in a quarry. If this theory holds even a grain of truth, it revolutionizes our understanding of the site. Puma becomes less a monument of subtraction, where material was painstakingly removed, and more a monument of addition, where material was intelligently assembled at a molecular level. It shifts the genius from the realm of physics and force into the realm of chemistry and knowledge. The builders were not superhuman stonecutters, they were ancient material scientists. They understood the land so intimately that they could deconstruct its components and reconstruct them according to their will. This transforms the high plateau from a construction site into something resembling an alchemical laboratory, where earth and knowledge were fused to create a new, obedient kind of stone. The implications ripple far beyond Bolivia. It suggests a forgotten chapter in the story of human innovation, where the manipulation of matter was approached with a sophistication we are only now beginning to rediscover in our own modern composites and polymers. The stones, then, are not carved mysteries, but cast questions, waiting for us to decipher the recipe of their creation. The silent stones of Puma have always had a voice in the stories of the people who live in their shadow. For the Aymara, the indigenous inhabitants of this high plateau, this is not a forgotten ruin, but a living part of their ancestral landscape, woven into the fabric of their oral traditions. Their accounts offer a perspective that archaeology cannot capture, a cultural memory passed down through countless generations. In these stories, the site was not built over centuries by an army of laborers. Instead, it was created in a single night by a race of giants, or by their own ancestors with the direct assistance of the gods. To the modern ear, these tales sound like pure mythology, fantastical explanations for something incomprehensible. But to dismiss them as mere fiction is to miss their profound insight. These narratives are not attempts at literal history, they are powerful cultural codes. They encode a fundamental, enduring truth about how this place has always been perceived. The very essence of the stories, the theme of creation happening in a blink by beings of immense power, tells us something crucial. For as long as people have lived here, Puma has been understood as an anomaly. It was seen as a place where the ordinary, slow, human process of building was transcended, where achievement leaped into the realm of the extraordinary. The Aymara oral traditions do not describe a long, grinding construction project. They describe a miraculous event. This persistent view, stretching from the deep past to the present, validates the core feeling that strikes every visitor today. That sense of awe, that whisper that something here does not fit, is not a modern invention. It is an ancient recognition, preserved in story. These perspectives remind us that the mystery of Puma is not just a puzzle for scientists and engineers. It is a human mystery, one that has inspired wonder and explanation for over 1,000 years. The Aymara saw the same impossible precision we see, and their response was to elevate its origin to the divine or the superhuman, because no ordinary human effort could explain it. This cultural memory challenges the slow, patient timeline of conventional archaeology, not with carbon dates, but with a timeless human intuition. It suggests that perhaps the builders themselves were so advanced, their methods so efficient, that to later generations, their work appeared to have been accomplished almost instantaneously, as if by magic. To stand between these two worldviews, the scientific and the traditional, is to stand at the heart of the enigma. One seeks answers in the chemistry of stone and the patterns of erosion, the other in the language of myth and memory. Yet both are staring at the same profound reality, a collection of stones that quietly, insistently, refuses to conform to any simple story of the past. The scattered stones of Puma do more than puzzle archaeologists. They challenge the very story we tell ourselves about humanity's past. Our conventional history is a comforting narrative of linear progress, a steady climb from simple stone tools to complex machines, each generation building directly upon the last. We place cultures on a tidy timeline, labeling them primitive or advanced based on the artifacts they left behind. Puma refuses to sit quietly on that line. It is an outlier, a data point that disrupts the entire graph. If this site was built with only stone hammers and copper chisels, it forces us to dramatically recalibrate our understanding of what is possible with those tools. It means that human ingenuity, when fueled by a unified cultural vision, can achieve a level of precision and scale we once thought required industrial technology. This view elevates ancient peoples from being merely clever to being masters of their material world, achieving through patience and collective what we achieve through gears and engines. Their timeline remains intact, but our respect for their capability must expand exponentially. But if the evidence points toward a different explanation, if those machined surfaces and standardized components hint at a lost science, then the implications are even more profound. It suggests our timeline is not a straight, ascending line, but perhaps a circle or a series of peaks and valleys. What if human history is punctuated by periods of advanced knowledge that rise, flourish, and then are catastrophically lost, buried under floods, ice, or the slow erosion of time? In this view, Puma is not a pinnacle of its known era, but a surviving fragment from a previous peak, a piece of wreckage from a forgotten age of innovation. This possibility does not diminish the or any other culture. Instead, it places them within a much deeper and more mysterious human journey. It means that progress is not guaranteed, and that knowledge, no matter how sophisticated, is fragile. A single cataclysm can reset the board, leaving later generations to stumble upon the artifacts of their predecessors and wonder, as we do now, how such things were ever made. This is ultimately why the mystery matters far beyond an academic debate about stone-cutting techniques. It is a lesson in intellectual humility. Puma stands as a permanent, stone-built question mark, reminding us that our current understanding of history is a work in progress, a best guess based on the fragments that have survived. It cautions us against the arrogance of assuming we know the full scope of ancient human capability. When we encounter something that does not fit our models, we have a choice. We can try to force it into the existing box, sometimes straining logic to do so. Or we can allow the anomaly to expand the box, to make our vision of the past wider, more complex, and more wondrous. This site invites us to stay curious, to question comfortable assumptions, and to remain open to the possibility that the ancient world was a place of deeper, more diverse genius than our textbooks have yet captured. The true value of Puma may not be in providing a definitive answer, but in keeping a vital question alive, a question that echoes from the high Andes to the core of how we see ourselves, our ancestors, and the long, winding path of human discovery. The stones have presented their case, and we have heard the arguments from every side. So where does this leave us, standing amidst the scattered evidence of Puma? A truly balanced view must acknowledge the strengths and the gaps in every perspective. The mainstream archaeological stance, which credits the culture with achieving this through immense, skilled labor, is not just plausible, it is a testament to human potential. The organization, the patience, the sheer will required for such a project is itself a kind of miracle. Yet, as we have seen, this explanation is visibly strained when pressed against the physical reality of the cuts, the precision of the angles, and the staggering scale of replication. The stones themselves seem to push back against the idea of endless pecking and grinding, their surfaces whispering of a different, more efficient process. On the other side, the alternative theories are undeniably compelling. The idea of a lost ancient technology, or even a forgotten high science, solves the precision problem elegantly. It provides a tool equal to the task we see before us. But here we encounter a different kind of strain, a lack of definitive, corroborating proof in the archaeological record. No advanced machinery has been unearthed, no manuals discovered. We are left with a magnificent effect, searching for a cause that remains just out of reach. Perhaps, then, the truth resides not at the extremes, but in a complex and sophisticated middle ground. What if our mistake has been in underestimating because their most ingenious tools were not made of durable metal or complex gears, but of knowledge? Imagine a suite of highly refined techniques, now lost to time because they relied on perishable materials and closely guarded oral traditions. They may have used advanced abrasive compounds, far more effective than simple sand, perhaps mixed with specific plant saps that altered their cutting properties. Their measuring and guiding tools, likely made of wood, cord, and polished stone, could have achieved a level of precision we would not expect, serving as the jigs and templates that made standardization possible. Their true genius may have been a profound, empirical mastery of their environment. This was not magic, but a deep physics of place. They could have harnessed hydraulic power from lake, with cleverly engineered water channels to drive abrasive saws. They might have used focused thermal shock with such control that it allowed them to split and shape stone along predetermined lines with startling accuracy. This is not about alien intervention, but about a culture that achieved a perfect synergy with the elements, turning water, sun, and mineral into a precision toolkit. Their technology was an integrated system of applied knowledge, where the line between craftsmanship and applied science simply did not exist. In this light, Puma likely represents the absolute zenith of a specialized stoneworking tradition, a tradition that took generations to perfect and may have been snuffed out in a single catastrophic event. taking its deepest secrets with it. The builders were not primitive, nor were they visitors from another world. They were brilliant engineers and artists operating at the peak of their cultural evolution, using a sophisticated, holistic understanding of materials and forces that we, from our industrialized vantage point, have struggled to recognize. They solved problems with solutions that were elegant, effective, and ultimately ephemeral. The site, therefore, is not a contradiction to human history, but a profound expansion of it. It asks us to widen our definition of technology and to respect the possibility that ancient innovation could follow paths we have forgotten how to see. The legacy of Puma is not a single answer, but a permanent invitation to look deeper, to question our assumptions, and to marvel at the boundless creativity of the human mind when faced with stone, sky, and an impossible vision. The story of these stones is far from over. While we have walked through the theories and marveled at the evidence, the final chapter of Puma remains unwritten, waiting in the silent earth beneath our feet and in the laboratories of tomorrow. This is not a closed case, but an active investigation, and the tools we bring to it are evolving faster than ever. The next great revelations may not come from a new theory, but from a new way of seeing. Imagine sweeping a ground-penetrating radar array across the plateau, not just where the stones lie scattered, but across the open, seemingly empty spaces. This technology sends pulses into the earth, painting a picture of what lies below without moving a single grain of soil. It could reveal the ghostly outlines of foundations we never knew existed, mapping the full, original footprint of the complex. It might detect buried chambers, hidden pathways, or the organized patterns of a lost workshop city, finally providing the context that has been missing for centuries. This subsurface map would be a game changer, turning speculation about the site's grand design into a tangible, digital blueprint. Beyond mapping the unseen, future science can listen to the molecular story locked inside the stone itself. Advanced material analysis has grown incredibly sophisticated. Researchers could take microscopic samples from those flawless cuts and drill holes, searching not for what is there, but for what was once there. Using techniques like residue analysis, they might detect trace elements of ancient binding agents, metallic particles from long-corroded clamps, or even organic compounds that hint at the use of plant-based solutions in the working process. A spectrographic scan could reveal heat signatures, subtle variations in the crystalline structure that indicate whether a surface was shaped by gradual abrasion or by a more focused thermal process. The stone itself is an archive, and we are only now developing the vocabulary to read its most subtle entries. Of course, the most definitive answers often come from the slow, careful work of the trowel and brush. Continued, meticulous archaeological excavation in the broader region holds immense promise. The discovery of a dedicated tool-making workshop, a cache of specialized implements, or even a single, unambiguous diagram carved onto a slab would instantly reshape the entire debate. Finding the tangible, physical tools that match the precision of the work would provide the missing link, closing the gap between capability and evidence. Every new season of digging is a chance to find that one transformative artifact. Perhaps the most important shift needed is not in technology, but in perspective. Puma resists explanation because it exists at the intersection of too many disciplines for any one field to claim it. The path forward demands a true multidisciplinary conversation. We need archaeologists to provide cultural context, materials scientists to decode the stone's composition, structural engineers to model the forces at play, and even experts in acoustics to explore the potential role of sound. By weaving these threads together, a more holistic, nuanced picture can emerge. This collaborative approach treats the site not as a singular puzzle, but as a complex system where artistry, physics, spirituality, and innovation converged. Ultimately, Puma remains one of history's most captivating open invitations. It does not mock our ignorance, but challenges our curiosity. It calls out to a new generation of thinkers, explorers, and scientists to approach its riddles without preconception, armed with both cutting-edge technology and an open mind. The greatest tool we can bring to this high plateau is not a radar or a spectrometer, but a willingness to be surprised. For in the end, the true legacy of this place may not be in proving how it was done, but in demonstrating how much we still have left to learn about the brilliant, boundless ingenuity of the human past. The stones have been patient for centuries, and their deepest secrets are waiting. That silent challenge carved in andesite forces us to confront a humbling truth. The precision stonework at Puma stands not as an answer, but as a profound and enduring question. Whether you see it as the ultimate monument to human perseverance with primitive tools or as a scattered relic of a forgotten science, it commands a single, undeniable response. Our deepest respect and unending curiosity. This site does not fit neatly into our timelines or our textbooks. It exists in the gaps, in the spaces between what we know and what we can scarcely believe possible. In doing so, it performs a vital service. It reminds us that history is not a closed book, but an ever-evolving puzzle, a grand narrative with crucial pieces still missing, waiting to be found or perhaps forever lost. As we leave these windswept stones behind, it is worth reflecting on what they ultimately represent, beyond the debates of tools and timelines. They are a testament to the timeless human drive to create, to build, to impose order and beauty upon a chaotic world, and to leave a mark so indelible it defies time itself. That impulse to reach for the impossible and carve it into reality is a thread connecting every great civilization, from the unknown builders of this high plateau to our own modern wonders. Puma may guard its secrets closely, but in its very silence, it speaks volumes about who we are and what we are capable of when vision, will, and ingenuity converge. The mystery remains, and perhaps that is its greatest gift, a permanent invitation to wonder, to question, and to keep searching. If you found this journey into the heart of one of history's greatest enigmas as fascinating as we did, we would love to hear your thoughts. What theory resonates most with you? Share your perspective in the comments below. For more explorations into the lost chapters and hidden wonders of our past, be sure to subscribe and join us as we continue uncovering the stories written not in ink, but in stone.